Hey Precal! So today we are in Pandemic Education, episode 4. Today we're going to go over Unit 9, Lesson 2, Part 2. Let's get into it. All right, so Unit 9, Lesson 2, Part 2. Our objective for today, we're going to be finding the inverse of exponential and logarithmic functions. So I've been telling you that exponential and logarithmic functions are inverses of each other. And I want you to take a second and look at these two different graphs that I have and try to tell me why. So think through it. There's 3 reasons for functions to be inverses, or for a function to have an inverse. Remember, it has to be a function and it has to pass a certain test. So I want you to think through it, and when you're ready, keep going. And I'm pause the video, think through it, and when you're ready, resume and you'll see why. All right, so the red lines are exponential functions, and then our blue lines are our logarithmic functions. So remember that for a function to have an inverse, it first has to be a function, which means it passes the horizontal line test. I'm sorry, the vertical line test. For a function to have an inverse, it has to pass the horizontal line test. And both of these functions do pass that horizontal line test. They're also one-to-one functions. Remember, for each input, there's exactly one output. Now, these functions are inverses of each other because if we take our exponential function, that red function, and fold it, reflect it across the line, y equals x, we end up with our logarithmic function. And same thing for logarithmic, folding it over the line y equals x, we get exponential. So I've been telling you that they're inverses, but here's exactly why. They're one-to-one functions. They reflect across the line y equals x, and they pass that horizontal line test. So it's been a minute since we've actually found inverses of functions, so here are our steps. We have our original function, and usually it'll be written as f of x equals something. If you have that f of x, change that notation to be y. It's a lot easier. The next step is that we flippity-flop and switch all of our x's and our y's. So wherever there's a y, we write x. Wherever there's an x, we write y. Then we use our knowledge and properties of exponents and logarithms and, inverse operations, et cetera, to get y all by itself. The last step, and this is really important, is that we need to change y to the negative 1. Remember, that's our way of saying the inverse of. If your original function is written as f of x, I want you to change that y into f to the negative 1 of x. Make sure you take a second and rewrite so we can tell the difference between the original function and the inverse function. If you need to write these steps down, pause the video, make sure you get them jotted down in your notes, and then we're going to do some examples together. All right, so let's get this up and running. Here we go. Okay, so I'm just going to write these down in my notebook. I'm pulling these problems from the worksheet we were looking at yesterday, right? This INM page. I don't know if I posted it, but I'm writing all the problems here. I'm just going to show all the work on paper because I don't have enough space on that worksheet. So this is my original problem, and the directions say to find the inverse of each function. So my first step is to make sure that it's written as y and not f of x. Cool, already done for me. Now we're going to go through, and everywhere there's a y, we're going to write x. And then everywhere there's an x, we're going to turn it into a y. All right, so now we need to get y by itself using our inverse operations. So I see that I'm taking the log of y. How do I undo log? With an exponent. This log doesn't have a base. So take a second and think, what is the base if I don't tell you one? It's base 10, right? That's our common log. So to undo this, I'm going to do 10 to the, and whatever I do to one side, I have to do to the other. So I've got 10 to the x, these are going to cancel, equals y plus 10. Oops. I started writing my parentheses, but I realized now I don't need them anymore, right? I was taking the log of this whole thing, but now that the log is gone, I don't need these parentheses anymore. Okay. So now to get y all by itself, the last step is we're going to subtract 10 from both sides. And we get 10 to the x minus 10 equals y. Final step is to make sure that I indicate that this is an inverse function. So I slap that little -1 on that y. We put a box around it, and we are good to go. All right, let's do another one. I'm just going to move over a little bit. Our next problem, example number 2, is y equals log of x minus 2. All right, step 1, make sure that it's written as y and not of x. Easy peasy, done. Next step, we are going to flippity flop our x's and our y's. Everywhere there's a y, I write x. Everywhere there is an x, I write y. So now looking at this problem is different from our first one in the sense that in the first problem, I was taking log of the entire thing, right? Over here, I'm just taking log of y. So to get y by itself, the first thing I have to do is move this 2 over. Remember, because we're isolating a variable, we have to look for addition / subtraction first, then multiplication / division. Oops. Then things like exponents. And in this case, this is exponents like / logs, right? Because they go together. And then parentheses. So we're going to add 2 to both sides first. So I've got x plus 2 equals the log of y. And now we need to undo this log. So if I don't tell you what the base is, what is the base? It's 10. So I need to do 10 to the on both sides. These will cancel, and I get y equals 10. And then the entire exponent is all of this. So I'm going to put parentheses around it so I don't confuse myself. 10 to the x plus 2. I put it in parentheses nice and high and a little smaller. So I know that the entire thing is in the exponent and not just the x piece. Last step is to put a little -1 on there so we know that this is an inverse of the function we were given. Okay. I've got 4 more examples, so I'm just going to kind of keep working through them. Example 3. We've got, this is a good one, y equals 10 to the x over 4. Okay, make sure it's written in y notation, step 1. Check. Step 2, flippity flap our x's and our y's. All right, step 3, we are trying to isolate our y variable. So remember, we do PEMDAS in the reverse order. So is there any subtraction or addition? No. Is there is there subtraction or addition? No. Is there multiplication or division? Yes. Let's undo this division that we see. To undo division, we have to multiply. So I'm going to multiply both sides by 4. Those go away, and we get 4x equals 10 to the y. How do we undo this exponential feature we have going on? How do I undo an exponent? Well, we use a log. Remember, they undo each other. They're opposites. They're inverses. So I'm going to do a log base 10 to cancel out this base 10 in the exponent that we have going on. I'm not going to write a 10. I'm just going to use log because I know if I just write log, I mean base 10. Whatever I do to one side, though, I got to do the other. Those go away, and so we get log of 4x equals y, and I'm going to slap that little inverse notation on there so I know this is the inverse function. Again, I like to put parentheses around whatever I am taking the log of. It's really helpful. Please just be as specific as you can with all of these problems. Okay. Number 4. Y equals 10 to the x plus 4. Make sure we've got y notation. Check. Flippity flop our x's and our y's. Now we gotta do inverse operations to isolate this y variable that's up in the exponent. So I'm gonna subtract 4 from both sides. Oh, damn. x minus 4 equals 10 to the y. If I want to undo this exponential base 10, I need to take a log with the same base. So I'm going to do log base 10. I'm just going to write log because, again, log with base 10, standard log is base 10, so I don't need to specify the number. Whatever we do to one side, we got to do to the other. Those cancel, so I'm doing log. Again, here's why parentheses matter. Over here, it's super obvious that we're doing log of 4x. But over here, log of x minus 4, I need to take the log of the entire thing. So just throw it in parentheses. Don't confuse yourself. Don't confuse anyone else. Use your parentheses and use them wisely. This y comes down. I need to slap my little -1 up here so I can notate that it is an inverse function. Put a box, and we're good to go. All right, 2 more examples, and our last 2 examples have to do with natural log. We've got some e's in here, so this should be good. This is example 5. It says y equals ln of x plus 8. As a reminder, with my natural logs, I make my L's look like this so they don't accidentally look like 1s. Just a personal preference for math notation for me. Step 1, make sure we've got y notation. Step 2, we're going to rewrite this and flippity-flop our x's and our y's. Okay, so I look for addition and subtraction. I see addition, but it's happening inside of this natural log, so I cannot subtract 8, right? To get this 8 out, I have to first get rid of this natural log. I can't just pull it outside of my function. So look for addition, subtraction. Nope. Look for multiplication, division. Nope. Now we look for exponents and logs, and we undo them. So I have a natural log. This is really log with a base of e. So if the base is that e, which remember equals 2.7, 2.17? Give me a second, let me double check. 2.718, there we go. So 2.718, and it keeps on going forever and ever. To undo this natural log with a base of e, I'm going to put it to the e to this power, and they'll cancel each other out. Remember, whatever we do to one side, we got to do the other. So this exponential base e and this log base e will cancel out, and my log base comes out. So I've got y plus 8, and then over here I've got e to the x power. All right, we're still not quite done. Let's subtract 8 from both sides. Then we get e to the x power minus 8 equals y. Last step, make sure you notate that it's an inverse of the function, and then you can box it and move on. Okay, last but not least, number 6. Okay, we've got y equals e to the x over 3. Oh, sorry, negative e to the x over 3. So make sure we've got a y. Check. Let's flippity-flop our x's and our y's. So look for addition, subtraction. There isn't any. Look for multiplication, division. I have division. I'm going to undo it with multiplication. So I'm going to multiply by actually a -3. Remember, this negative sign out in front can be applied to the numerator, to the denominator, or to the whole fraction. So by multiplying both sides by -3, I'm able to cancel out the 3 and this little negative sign and have a positive e to the y. So now I've got -3x equals e to the y. To undo this exponential base e, I have to take a log with the same base. That's log base e, which is better known as natural log, ln. Whatever I do to one side, I got to do the other. These will cancel. My exponent comes down, and so I get y equals the natural log of -3x. Okay, slap a little inverse on here. And we are good to go. Now, for these problems, I did not specify that you needed to restrict domains, but let's talk about it for a second. what kinds of values am I not allowed to put in for x? If x is 0, negative 3 times 0 is 0. Can I take the natural log of 0? No. Okay, so x cannot equal 0. Okay, if x is a positive number, let's say positive 2. Negative 3 times positive 2 is negative 6. Can I take the natural log of negative 6? No, I can't take the natural log of a negative number. So x cannot equal 0 or positive numbers. So what can x equal? Well, x can be anything negative because a negative number times a negative number will give me a positive inside of here, and I can always take the natural log of a positive value. So if I asked you to restrict the domain, you would need to say x, it has to be less than 0, right? It has to be any negative number. Just as like a little bonus problem there for you. Okay. So with all that being said, that's it for our lesson. If you have any questions, comments, or concerns, please send me an email, come to the Zoom meetings, and try these practice problems. I'll post a whole bunch on Google Classroom, and when you feel ready, try the assessment. I look forward to seeing you soon, and I love you lots. Bye.